Hello everyone and welcome to Handmade Hero, the show where we code a complete game live on stream. This is a third day, I guess, of particle stuff that we are doing. We're just trying to put in some particle system infrastructure for ourselves to use so that we can start having particle systems that actually are in the game proper. We did a long time ago some test stuff with particle systems just to kind of show, I wasn't really test stuff, I guess I just did sort of an introductory thing on those. And now we like to make it so that they can be in the game for reals, not just as a little piece of test code to show how they work. So I thought of something, and I kind of wanted to mention it because I was thinking that maybe it's something that we'll have to, that is suggests that my approach may not have been so good so far and that we should maybe sort of reconsider. I was thinking about it in the shower this morning, as is often inevitable. Oops. Gotta restart that guy. Give him my Milton. There we go. Let's see. Day 338. So, this is basically like a particle cache talk. So what I was thinking about is I was trying to think about what sorts of things I wanted to enable. I was kind of just idly thinking about them. And what I was realizing is that the way that I was structuring the particle cache was probably not really what I wanted. And here's why. So I had sort of been structuring the particle cache as if the main case that we were trying to handle was something like, oh, you know, here's like a little fountain or something, and there's like some water coming out of the fountain, right? And so the fountain would be an entity, and it would have a particle, system on it. Wow, okay. A particle system on it. And then what would happen is, when this came on the screen, the particle system cache would wake up and say, oh, okay, I need to have a particle system here for the fountain. Now that's a perfectly reasonable thing to do. If what you're planning on is having a few discrete particle systems around the screen, that are doing whatever they're doing. But what I realized is that's not really the game that I'm making here. I don't think that's really going to hold up because let's suppose that I want to do something like this, where I've got, trees around here, right? And I light one of these guys on fire. And now there's fire spreading to all these trees, right? Well, I definitely don't want to create a different particle system for each fire, right? Because, it quickly would balloon out into way too many particle systems, especially if there were other particle systems happening, like wind or water or whatever happening. And so what I was realizing is it's like, well, really I think what we probably want is to say that there's just a particle system that's the full screen, for fire, and anything that's on fire is spawning particles into that particle system, so that we don't really care how much fire spreads out throughout the world. We can always handle it and degrade more gracefully than the problems that we would have if we had to have each individual one of these fires be a particle system now. Right? So I think my approach was just kind of fundamentally not great in that sense, right? And so what I'm thinking is that actually we probably don't need the particle system cache at all. Probably, I mean, we do need the particle system cache. We just don't need it to cache particle systems by entity ID or anything like that. Probably all we need to do is have entities spew particles into the particle system. If they're on fire, they just generate fire particles. And then the particle system takes care of remembering that and handling those particles, right? That's a much saner way to do it, and I'm not sure why I wasn't going to do it that way in the first place. Probably just because I didn't think it through enough, or who knows why. But so I think the problem is actually a little bit simpler than what I was making it out to be. Now there is some, there is a little bit of a caveat here, which is that the particle system is like going to be a fixed thing in space. So as we move around, right, as we move the particle system around, during each pass through the particle system, we have to displace the particles by the camera. Because the particle system is just a fixed thing over the screen, so if the player walks to the left and the camera is moving, then we need to shift all the particles to coincide with that. Because the particles themselves are never going to really be in the world space. They're always kind of just in the local simulation space. They never get stored back out or anything like that, right? Oh my goodness. Okay. But I think that's what we want. I think that's just a smarter thing. And so I feel like we can just kind of eliminate that part of the code that we had before. By the way, for those of you following along at home, today's is day 338. So you want to use that. You want to use 337's source code if you're trying to follow along with me today. Okay, so essentially the particle system thing, all of this stuff that we were working on can stay exactly the same. The difference now is that these particle systems are not going to be things that are based on some kind of a cache. They're going to be something based on how many different sort of discrete particle simulation arenas we're going to need. So at the moment, we could just say that we just have one kind of particle system, and that's the fire system or something like that. We don't need this, and we don't need this. And so, because we're never going to do any of that caching, and we don't need the touching, the frame touching, and that stuff. So we can get rid of this, which is nice. We can get rid of basically every thing that had to do with particle systems other than just the basic particle system piece itself that we were kind of playing around with. And the particle spec would really be more of a particle emitter specification kind of a thing. And we don't really even need that to be in there anymore. Now let's go ahead and that also means we can unwind one of kind of the stupid things, the entity ID bit we had to move in order to make that work. We can also unwind that and put that back in here, I believe. That should work just fine. At least I think so. And so the particle system spec stuff can go away temporarily, and we'll continue on. All right. So let's see what we've got here. All of this stuff, I guess, is still the same, because this is just operating on particle systems. It's not operating on the particle system cache. Anything that's operating on the particle system cache, however, is going to have to change. Get or create particle system is never going to be something that we need to do again. So in theory, all of this stuff can just go away, right? I think we can just say, you know what, that is just completely unnecessary. So is touch particle system. Those are just not things anymore. So really, it's only update and render particle systems, and really this time, for the update and render particle systems, we would just, I think we've got one here, whatever. Yeah, we've got that play around thing. Really, we do update and render fire, let's say. So if we've got update and render fire, I'm just going to go ahead in here and say, like, okay, for update and render fire, we'll just call that in here. This stuff is not necessary anymore. And we can just say, what is that, fire system? And that will have everything that it needs to work with. When we do init the particle cache, again, that's something that we don't really have to worry about too much. We want all our particles probably initialized to 0, so at least, or do we? I don't really know. That's a good question. Probably we do, which in that case, I think that does mean we could have left the right clear in for our particle systems, in which case we don't really need an init particle cache really for anything. I have to think about that. We can leave the call in, but I just don't know that it actually matters at all. But yeah, when we do this world struct and we do the no clear, I guess what I could do is I could just clear it here for now, and then if we decide that we don't need to clear it later, we can eliminate that call. So yeah, let's take a look at the rest of this stuff. The particle spec for init particle system. Init particle system is not going to happen anymore. It would be per particle system if we actually did need to do some initialization, which we don't. Update and render fire needs to take some entropy. At the moment, we don't have any entropy, so we probably want to use have the cache have its own entropy source, I would imagine. So something like this, random series entropy. And that entropy is not gameplay sensitive at the moment. So this is, effects or particle entropy. Note Casey, not for gameplay ever. Right? Because that's just some, going behind my head there. So yeah, we want to, when we initialize this, I guess there's something we can do that's initialization based. So particle entropy, I don't know what random series has in it. Probably it's got like a seed or something like this. Do we know? Do we know how to seed one of these guys? Let's see. Random seed. There it is. So we just want to random seed this guy with, I don't know, 1, 2, 3, 4 for now. It doesn't matter. We just need to get entropy from somewhere. So once we have some entropy, then we will just say, okay, yeah, you can use our entropy system and go to town on that. Function does not take 4 arguments. Well, why don't you tell me how many it does take? It takes a system, an entropy, and a DT, so it doesn't take a render group yet. It will, I would think, but we won't pass it yet. If it doesn't want it, that's fine with me. So, moving on. This comes after, yes? Yes. So now this thing doesn't have to do anything. The particle system stuff doesn't have to get packed or unpacked. And then I think we're good to go. So this is all fine now. Although that's odd. This is slower than it should be. Is update and render fire actually that much work? Let's find out. That was not what I wanted. Look at that. Why is that so slow? It's not really doing very much yet, is it? I guess our little experiment with the sliced, with those sort of ways of doing expressions is not very good, right? Remember I was kind of playing with how can we write something that's like friendly in terms of what it says SIMD-wise, and looks like that's not so useful because you can look at how much that is. We could see if it actually, does the right thing in release mode, but it definitely doesn't do the right thing in non-release mode. No, it's just awful. Interesting. So I guess my little trick is not particularly good, or at least the trick I was doing, unless I'm missing something, but it looks like it's not particularly good. Because remember, I was sort of playing around with, can we write these things as math functions? And it does not look like you can, unless I'm missing something. So yeah, maybe that wasn't so good. I don't know. I guess what we could do is say, put off the SIMD until we're done, and then SIMDize it. Because I was kind of hoping it could just run in SIMD in general, and we could just have some way of writing the math functions kind of relatively cleanly. But I don't know if that's plausible at the moment, if that really is the case. Now, maybe it's something else that's going on wrong here, but, you know, assuming it's not, that's not great. So So what do we want to do? You know? What do we want to do here? How do we want to tackle this? Do we want to write this in non-SIMD first and then SIMDize it later? Or do we want to try writing it in SIMD from the start and keep it relatively fast as we go? I really don't know. I mean, what I want to do is be able to just write this in a nice, concise fashion that then can be turned into SIMD code, because it's obvious how to turn it into SIMD code. Like, it's not... There's nothing subtle about this this particle code. I'm literally just asking it to do 4 of the same op on an array all the time. I just can't think of a good way to do something other than what I did. That isn't super sort of difficultly sloppy. Let's think about this. So I guess one thing we could do, if we don't particularly care about how wide we go, like if we don't want to go arbitrarily wide, we could do something else. So let's think about this. So one thing we could do is we could say, well, all right, we've got these, you know, these guys here that are sort of these sliceable guys who have an x, who have like a 4 of each, 4 x's, 4 y's, and 4 z's in them. And what we could do is say, like, all right, you know, maybe we've got a particle is actually 4 particles or something, and we just have a v3 4x, you know, of p, v3 4x, dp, you know. So it's the same as it was before, but just everything is 4x'd now. Oops. Right? And so then, you know, a particle system is just a particle 4x. And there's, you know, a quarter the number of particle 4x's as we want particles, you know, and off we go, right? And then this thing goes away, like we don't need that anymore. And we just have these guys that operate on the bundles of 4 at once. Right? So, you know, if we did something like that, I don't need this either. So if we did something like that, we could maybe start to get things into a slightly better shape. We would not need getParticle, right? That would not happen anymore. And in here, what we could do is say, like, all right, you know, we've got a particle A, and that particle A is just whatever the particle that we're supposed to be on. I guess that's AI. So now we've got a pointer, and then from there we can just say, like, okay, we want to initialize all of these guys, and we can do that exactly the same way, right? So the code looks almost identical. If we look at it, right? And now, you know, the hope is anyway, this will be much more easy for the compiler to understand what we're doing. It's not all like super contorted like it was before. So the hope is, you know, maybe that would take the pressure off it and allow it to work. I don't actually know, but that would be the hope. What is this particle 4x? Does not have an over... Oh, right. These are dots now. Oops. So again, just pull one of these out. And think this would be a lot nicer too. Look, that looks a lot nicer too. So I think all we have to do is add the plus equals operator in there, because we never did one of those. We had done that for the particle v3, but we'd never done a plus equals for just the 4x and the 3x guys. So if I just go ahead and do that one, where are the... Oh, the 4x ones we haven't done yet. All right, I was going to say, where are the 4x ones? So if we do a plus equals for this guy, we should be able to just kind of do this in place, like so. And I think that's it. We're still in optimize mode. I didn't actually want it to be in optimize mode, so let's see how we do here. So you can see how like basically we were doing exactly the same mathematical operations, right? We have not changed any of the math, but just the compiler could not figure out the kind of machinations we were doing there. So this is a lot nicer. Now we've actually gotten rid of the things that it probably thought it had to do to make things work okay. And so that's a lot happier, right? Now it's a completely meaningless part, and it runs just fine, which is what I would have expected. All right. So yeah, do we need this anymore? No. So yeah, so that's a lot nicer, I think, because now we effectively have the ability to treat a particle as a mathematical, like, you know, infix notation thing that we can actually read. You know, I can read this a lot better, and I feel like that's going to be important if we wanted to actually keep it in SIMD the whole time, so it's you know, in debug mode still fast enough. I think that's just a better way to go. So yeah, so let's add the stuff that we're missing here. I'm going to go ahead and get rid of the if, because in SIMD that's going to be a little tricky, so we'll have to see how we want to do that exactly. But then we can kind of move on to working on some of these other things. Okay, so I think that's that. We should now have to write these operators, the ones that we wrote. We should have to write them for the v3, v4, and that sort of stuff. So really, I think all that is just, you know, changing these guys to v4s and just adding the w. That's really it. And again, if you're a template sort of person, this is possibly a place you could use those, or things like that. If you have some way of accessing generic programming in your language that doesn't make you want to throw yourself in front of a bus like C++ does, this would be a good time to maybe break that out. So yeah, let's see. Oh, right, these are labeled slightly differently. Just to make things easier on myself, I'm going to go ahead and anonymous union these guys. Right? So that way I can access them as either one. And now, still good. No worries. So now we're doing part of the updating that we wanted to do for our particle systems, the old essentially the old particle code, is now SIMDized, and like I was saying before, it seems like we can do this pretty easily. Like this looks like the kind of thing where I can leave it in this code and I don't really have to worry too much about it. I can also, now that we've got this sort of a little bit more under control, I could say like, all right, instead of AI, I can actually make this be called what it actually is. So we kind of know roughly what we're doing here, and everything else here I think is fine. So that's all good as well. All right. So yeah, so I'm reasonably happy with how that turned out. This is kind of one of those things, at least hopefully it's relatively self-evident from, if you just take a look at what happened in the past 15 minutes or so, I feel like that's just a good example, if in case it wasn't obvious, of why it's important to actually like do all the things that we talk about doing on the stream, right? First of all, the fact that I had heads-up profiling on there was the thing that let me know that we were slow right away, right? Because I never would have known how busted that code was till later when I went to try and actually performance optimize it or figure out why my game was slow. Who knows where down the road. But because we always have all our heads-up stuff running, we know the instant something is taking more time than we think it should be, it's like, what's going on? Right? And we can jump right to it and see like, okay, this thing is not performing the way we want, right? So again, I think we talked about that way back when people were asking like, why do you spend time with debug stuff before you actually need it? It's because part of the debug code is about knowing when things are broken, and you don't necessarily always know when things are broken. I mean, even just as something as simple as a frame rate counter, where you can kind of look at how many milliseconds of frame you're taking, is incredibly important to always have available, because otherwise you just never have any idea what your changes are really doing. It's very hard to perceive them unless they slow down things so obviously that you can't not see it, right? So there's that. And the other thing is, if you look at the difference between how much cleaner this code looks than if we were to write it by hand in SIMD, or even it even looks better than what we had before, the kind of clunky version. That just kind of underscores like how important it is to just actually take the time to figure out how to get something a little bit more right before you start writing a ton of stuff in it. Because we could have easily gone down that route and had the much uglier looking code, and then it just would have been this constantly compounding problem. Whereas now all the work we do on the particles will go and be pretty easy to read, and we know that it's relatively efficient. So we're really set up for success there in a good way. So that's what I would say about that. That's really all I would say about that. Anyway, so now let's take a look at what we would want to do here for rendering. Before I get into whether we want to start playing with some of this other stuff, we got to do a few more things here where we figure out what we want to do with rendering, and we also have to take care of that displacement thing that I was talking about before. So essentially what's got to happen here is whenever we do an update and render of anything, basically, we have to pass both the DT and we will have to pass additionally a frame displacement, right? So we need essentially a vector that is the thing that we need to displace all the particles by to handle the offset from the camera. Now, I won't actually do that yet. I'll leave it out so that you can see what happens when it's not there. But we'll just have to remember, I'm just going to put it in so we know that it's there, right? So when we update the position, we're just going to put in frame displacement in there. And then when we do update and render fire, we'll just have frame displacement be this thing that we sort of have in there that we haven't done yet. There we go. I'm going to move over here so I'm not cramping my style there. And it just won't do the displacement yet. So we'll still be able to see the bug that will happen if we don't do the frame displacement, and then we can put in the frame displacement and see it. So I don't want to like jump ahead there, but I just happen to know, right, that if we don't have that displacement, it's going to mess us up. Okay. So we've got update and render part systems, passing that displacement, not going to do anything yet, but we've got it in there. So what we need before we can actually see anything happening here is... Oh. And by the way, that's got to be lofted. Probably this. So what we need is just some function that can produce these. From input. So if I have a v34x, that's the result. I just want the result to be replicating whatever the input was 4 times, right? So I'm just trying to stuff the values like so. Frame displacement. But we spell it right. And off we go. So the thing that we have not addressed yet now is the rendering. So the first thing that I'm going to do is I'm just going to render these particles through the standard particle path. Obviously, the standard particle path is probably not what we want. It's going to be too slow. I talked about why. So we're going to want to go ahead and add a special path for particles or something. We've got a lot of ways we could tackle the problem, certainly, but I think we're going to want a standard way it's not really for particles per se, but just for things that render out of the same bitmap, lots of things rendering out of the same texture, basically. We want to have a path for that process. Okay. So now we can take a look at this and say, all right, we need a color here, and we need to push bitmap calls and positions and so on. Obviously, we can't really do those things because we've got 4 packed of these. So what we really need to do is, until we have a way of actually producing, like I said, that optimized buffer, we're going to have to go through each of the subparticles, right? So this is like in that pack of 4, we've got to go through all 4 and pull them out separately, right? So what we need to do first is we need to find the p-value, and then we need to find the color value. So each of these. For the entity transform, this should just be something that we don't really have to worry about. That will just be some transform for the basis of the particle system itself. So that's actually something that I assume can be passed in and just left set the entire time. Now, the bitmap ID is something that we don't really have yet. We're going to have to get that from somewhere. For now, I think we'll use the same trick we used before, which is to say we can use the head of the hero. And so when we do our init particle cache, we'll kind of do some stuff here for that. So what I'll do is say, probably I guess what I'd do is say, let's pretend for now that particle systems have a bitmap ID that is whatever the bitmap that they use. And we'll just say that you always have that available. We'll have to get that from somewhere, but we'll cross that bridge when we come to it. So just say use the system ID. The particle transform, that's just going to be something that is pretty much constant, I think. So it could be passed in here. I don't know if we need to pass it in here. We could also put it in here, but I'm just not sure about that yet. So I'm going to go ahead and take a look at how our transforms are generally created here. We want sort of a null transform. So I think probably the default upright transform would be the easiest transform to do. If we want it centered around the camera, we would want to do this. We'd want to do that as well, because that's sort of like where the sim center is versus where the camera is. Because the sim center and the camera center, I guess, are not always the same. I don't really know why we do that. I'd have to think about why we do that. I think we may snap the sim center to always be aligned to a floor boundary, whereas the camera can sort of move separately, right? I'm not sure about that, though. Don't quote me on that. So anyway, and of course, when I say don't quote me on that, I think we actually have a quote database, so it's kind of a bad thing that I say don't quote me on that, because someone could be quoting me on what I said not to quote me on that, which is not great, if that makes sense. So yeah, let's take a look. What I want to do is say the default upright transform, let's say maybe that's just what we use here. And so we'll just say that there's a particle transform in here for the particle system, and pretty much those will probably just be set and forgotten because they probably never need to change. But if we want to do something fancier with them later, we can. So I think we want to do something that essentially does that. When we push these bitmaps on here, now what we're going to have to do is we're going to have to take those pieces out, like I said. So we're going to have to do something where we say, like, okay, let's pretend that we're grabbing out individual pieces here. So like our V3 is going to be kind of a nasty way to get this. It's going to be something like APX, you know, the, I can't even remember what these things, let's see here. Let me see. I don't know where our particle systems code is. It's not loaded yet. Update and render file. So I want to know how I access the individual members. And I never remember because of the weirdest names. Okay, so it's M128 underscore F32. All right, so you can see what I'm doing here. I'm just plucking out those values. Again, we don't really want to be doing this, but we're just doing this so that we can use the standard render path first, get the particle systems working with that, and then what we'll do after we have the particle systems working with that is we'll go ahead and add a custom pipeline for getting the particle systems down to the card in a way that isn't too heinous, right? So that's what we need to do at the moment. So I think that would do it. Let's get this back in here. Okay, good. I don't know why object transform isn't defined yet. Is that not a thing? Is that included? Are particle systems somehow included before the renderer? Because there's object transform, and I don't know why the particle systems would be. Well, let's find out. Yeah, they sure are. I wonder if we can move them after. That's not a problem because that's just a pointer. So I think that's all good. None of the two overloads. Well, yeah, duh. Okay. So now that we're in here, we need to pass the render group now since it's actually taking it like we knew it would, but we never had it in there before. When we knit the particle cache, we now have to make sure that our fire system, it has to have a transform. That's the default upright transform for now, I guess. And the bitmap ID we'll have to get from somewhere. Now I don't actually know where we're going to get the bitmap ID from. I guess I'll probably pass something here to the particle system so it can do some queries and get one, you know. We'll see if we can do that. Let's go to entity. Actually, no, it would be world mode. So when we do add player, somewhere in here we do queries for this. So here we've got asset shadow, torso, cape, head. So I guess when we do the pieces, we actually call them out at that time, which I guess is good. So if we wanted to do that, how would we do that? Let's see. Where's our piece iterator? There it is. So yeah, if we wanted to do that, we'd get this guy. Of course, we don't really have anything to match on because we don't have any assets for this, but it's okay. We could pretend and get the hero head or something like we were doing before. That seems fine. So if we did that, we could just say like, okay, let's just get like asset type, you know, or what was it again? Asset head. So we'll just get some head out of here. And call it a day. Now, I don't actually know if that's everything we need, because I don't remember. But either way, we would have to pass the asset system here. Because without it, it would not be able to get any of that. Now, I don't know if the asset system has been loaded. It would have to be. So the asset systems are always loaded at that point, so I think we're in luck there. That's just easy enough. We don't have to worry about the initialization order of those things. They'll just work. Okay, so now we need to do some... oh dear. Oh God. All right. Well... yeah. That's going to cause a problem. Had not thought about that. This, I wonder if this is finally the straw that breaks the camel's back and forces us to zbuffer our stuff, which we've constantly tried to avoid, but that's going to be a tough one to think through. So yeah, if we push this many things into the sort graph, it's going to be an epic nightmare, right? I mean, we can get things working here with just a small number of particles, maybe like that, but I had not considered the sort graph problem that we have. So yeah, so now I think we are, at least in theory, generating particles, and now we have to just kind of go do the debugging to make sure they're getting placed in a reasonable location and that we can actually see them. But that's basically it. Now, how much time do I have? I don't know. I think we've got 15 minutes left. I need a way. I should probably put a countdown timer in here, which is like says how many minutes are left, because I don't actually know. I don't remember when we started. I think we did an 8:45 start, which means we'd have 9:45, so which we'd have 15 minutes. So I'm going to just do some debugging here, and we'll talk about that problem that we're going to have. Okay, so let's see. Handmade render. No. Where's my particles? Why does this thing not leave things open? I know we've been in that file. Like, can't I just tell it, like, have all my stuff? Why can't you just have all my buffers open? Why can't you be more like 4Coder? God. You know how many millions of dollars went into developing the software package and I can't even do like basic 4Coder things? Seriously. All right. So let's see. I need to do update. Oh, yeah. Update and render fire. So we need to take a look at what we are rendering. And if it makes any sense. All right, so we have our RGBA and our p-values. Those all look fine. So it may just be the case that we're just rendering in a place that we can't currently see because it's too far below something else or something like this. I'm not sure. I'm going to take a quick look up at Update and Render World so I can see what the camera location is. Well, if the camera is at 0, 0, 0, though, I would think that would have been sufficient. Now, what I could do, I suppose, is I could nerf everything else just so I can see if they're getting eclipsed by something else or not. Let's take a look here. Okay. So yeah, so our particles are doing their thing, and so we're off to a good start. So all we really need to do now is actually sort of make these guys spawn somewhere that we actually care. And then we can move on from there. Kind of a nice little twitchy head thing going on there. My goodness. All right, so we've got update and render entities, and really this bit here I'm going to make into a function called spawn fire. And I'm going to go ahead and grab that up here and make it look like that. Spawn fire will take the particle system cache. And it will get the fire system out of that cache. And if we take a look at the p-values here, what I want to do is say, like, okay, we're not going to touch any of this stuff yet, and it's not fire anyway, it's a stream of heads. But what we do want to do there when we spawn the fire is say, like, okay, we would like to tell it where we were going to spawn it. And then what I can do is loft that guy up, so I can say, like, okay, after we compute that initial starting p, we can just add in our at, right? So now we can spawn fire at a location. We still need our entropy, but the entropy is easy to come by. Oops. So that should basically be it, right? Oops. meant cache, not system. So now we should be able to spawn fire wherever we want to spawn fire. And so what I can do is I can say, like, okay, let's say that there's an entity that just spawns some fire. I don't know what, whatever. So if we've got an entity here, and maybe like if an entity is in its landing phase, whenever it lands, it spawns some fire. Why does it spawn fire? I don't know. That's not my job. I'm not a game designer. I'm just a programmer, and I decided that it's going to spawn some fire. So it's going to spawn it at wherever the entity's placement is at that particular point in time. And then it just needs to be able to get to the cache, which I believe it can do, because I think we've got that in here. Sorry, particle cache. So, in theory, I think we should be able to get that spawning. Of course, as I say that, I am not seeing any spawning occur, but I'm not sure why. I would like to know what the hero's location is at the moment. And I would like to know what our particle system's looking like. It kind of looks like it should be okay. I'm also gonna, you know what else I need to do here? To make this a little easier on us. I gotta get rid of the rooms. So we're only looking at one room. Oh, okay, so it's just the problem is just that we have too many particles being spawned. So it's working just fine. This is why we need a lot more than 64 particles. So anyway, that's all well and good. And so now these people are spawning just fine. Now, of course, we still have a problem. And that is, as we move the camera, this will not work properly, right? Because all of these things are camera relative. And so what I need to do is I need a way of moving the camera to the side quickly. So what I want to do is make it so that the door direction is going to be in line with us, and there's two screens, like so. And then I'm going to update the particle count a little bit just so we can see more. Right, so we've got all these particles here, and they're all doing their thing, or whatever has to happen, right? You can see them. And you see what happened there? All of them kind of stay in place even after you try to leave, right? It's not pretty. Now, of course, we kind of have to do something. We have to have these particles stay around a lot longer. And of course, like I said, we can't because our sort graph will explode. At least I assume it will. Like you can see, like look at that. It's just a nightmare because they're all overlapping is the problem, right? But anyway, you can see how that kind of is a complete disaster there. Yes, yes, I know. That looks like a separate problem. Why are we... What's happening there? Why are there two doors like that? Shouldn't there only be one door? Well. Oh, because it... okay, no. There's always going to be an extra... Yeah, never mind. I'm stupid. Never mind. Forget it. Anyway, so this is all I wanted to get at here, was these guys, as they kind of get sprayed up into the sky like that, you can see the particles just, they stay in one place when I move. And that's because all of these particles are existing only in screen space. They're not actually existing in world space, which is what we want, because we only want to be dealing with particles that are kind of local to the simulation region. So that's great, actually. But we need some way of not having that artifact as we kind of go from screen to screen or do any other kind of smooth scrolling effect. We don't want to have that happen. So if we want to fix that, what we need to do is, from one frame to the next frame, we need to remember where the camera was and then account for that shift by moving the particles by whatever that change, whatever that actual change in world space is, right? So somebody has to pass us, essentially when we do update and render particle systems, somebody has to pass us the frame displacement in from outside. So when we call that in here, we need to get the like frame to frame camera, like the delta, right? So we have to get that somewhere. So what we need to do is figure out sort of, we want to do a subtraction of where the camera was last time and where the camera was this time, right? And so if you imagine how we would do that, we would just need to say something like, well, okay, you know, on the first frame, we just wouldn't have any displacement, but in every frame thereafter, we'd want to take basically where the camera like was and do that diff, right? And so to do that, all I'm really going to do is say, well, okay, let's say there's a last camera P. And so all I'm going to do is say, well, when we get that camera P, and that gets updated, right? Let's see your camera. So we do begin sim. So yeah, here we go. So when we do nsync here, right, this is where the camera P would actually get updated, I believe. So when we have world mode camera P here, and we get the sim center out of this, and we have the world mode camera P. At this point, what I want to do is say, okay, take the last camera P and do the diff, right? So frame to frame, camera delta P is going to be subtract, and it's going to be the world mode camera P, and the world mode last camera P. And then after I've done that, I want to do world mode last camera P equals world mode camera P. So we can just do that, subtract, get the frame to frame delta, and be done with it, right? So now all we have to do is make sure that when we actually initialize things and we set it up the first time, that we also set last camera P to that value. All right, so off we go with our little particles there, doing whatever it is that they're doing. I wanted this to be landing, and I accidentally set it to hopping, it looks like. But now what we need to do is get that camera delta working for frame to frame. Now that's still not... That's not at all what I wanted. To say the least. So I believe we have an error here somewhere. Of course, let me verify that we're actually using it properly, but it was not very complicated, so I'm assuming I just have an error when I'm computing the actual frame displacement. When we take the frame displacement, we pass it through. And whenever we have the frame displacement in here, we add it, right? Yeah. Well, so yeah, so I don't know why that's a problem. But what I was going to say is I also had this, I wanted it on landing, but I accidentally put it with the one before landing. So that's an interesting case. Hold on a second. The other thing is before these particles are initialized, they're all stacked on top of each other. So one thing I would want to do, at least at the time being, is say if if c dot a is greater than 0. If it's not, don't push it. That way we won't be rendering like uninitialized particles. See, that should be doing nothing. So I'm wondering why that's actually taking any time. Because I feel like those alpha values should all be 0, right? I want to see what happens there. I don't understand why we're getting any effects from the particle system the first time around. All right, so here's our first time through. Oh, that's awesome. Greater than or equal to 0. Yeah. Well, guess what? It's always going to be greater than or equal to 0, or at least most of the time. I wanted that. Yeah. So there we go. So anyway, yeah. So our problem here is just that this frame-to-frame displacement is not being applied the way I would think it should. So the first thing I'm going to do is just make sure that it's actually getting applied properly at all. But I don't see how it couldn't be. But, you know, either way. So what I'm going to do here is just double check that it is getting it is getting done the way that I would have thought it would. I'm going to say frame-to-frame camera. Oh. This is going backwards. So there's that. Yeah, because that's the motion that would take you from the location of the last camera to the location of the new camera. Right? So here's where the old camera is. And this is the new camera. And so if I move the camera this way, everything on the screen should move that way. But I'm moving the particles in that direction. So I'm actually compounding the problem at that point, which is the opposite of what I wanted to do. So really we want this to be the opposite. So I think that's still the right name for that. But we just want to pass the negative so that they'll move counter to where that is. So yeah, so we'll start with that. But it still seems like they're staying in one place when I go there, so I'm going to have to look and see if I mess something up. I got to say, this is kind of funny having all these like particles. I think it feels like the camera's... I was going to say, it feels like the camera has an additional displacement, and it does, right? And it actually does. The camera and the sim center thing, there's the world mode camera offset, which is a separate thing on top of that, right? So we actually have last camera repeat. We also have last camera offset. That's kind of annoying. I wonder if we can make do without that. I know we had that for animation purposes. I don't fully remember why, to be completely honest with you. But anyway, I think because we wanted to lock it like to room, but so we actually need both of these. We need both of those, and so we want to say like, hey, subtract those two, and then add to it world mode camera offset minus world mode last camera offset. So yeah. So there we go. Now our particles are moving, I think, a little more properly. Of course, I don't really know, because it's a very quick transition. But let's make those guys die out a little sooner. uh, just just for fun. So when we spawn one of these guys and we have that delta, I'm gonna just shorten that up a lot. So the spawn particles will just kind of kick up and just be really, really sparse like that. All right, so now we'll see if these particles are... See, I feel like there's some weird thing happening there where why are we seeing when we cross over here, there's kind of like these old particles that look like there should have been somebody there to spawn them, like they weren't getting updated or something like this. But that doesn't really make any sense. So it still kind of feels like maybe there's a bug there with the updating. Yeah, so if the particles are being spawned, the transform, yeah, so I feel like I know what's happening there too. So I feel like what's happening there is when we do the transform, that camera offset is something that we're actually pushing on to the entity transform, right? That camera offset is getting pushed on here. So that means it's strictly a transform that's being applied to not to the entities themselves. Their locations are still relative to the sim center, right? So we need to either use the same technique for that, which maybe is the best course of action. So always use that world transform. Always just use that world transform for the particle systems, and then we wouldn't need to track the camera offset anymore. That seems like maybe a better idea. Because what's happening there, right, is that when the screen is displaced by just camera offset, our particles are spawning in the wrong locations, because those particles are being spawned in the entity space, which is not actually displaced, right? So you kind of have this situation where you really don't want, I really don't want that, I guess. So the camera offset could stay, and then that way we also wouldn't have to do this, which is nice, right? So we can just say like, no, that's not happening. So the camera offset stuff is the way it is. And then when we do the rendering of the particles, we just pass this world transform down as the transform to use. For everybody. And that way it will get displaced automatically, and then now everyone's in the same space, I think. I think that's will then be a much more maybe consistent way to do it. So if we get rid of this, we pass it down like so. And then we would just pass it through and everyone's happy. Well, I don't actually know if everyone's happy, but they might be happy. And probably that should be a pointer, huh? Okay. Almost done. Now I think we're good. All right. All right, we'll do some Q&A. Oh, Martins, thanks for the reminder. He's pointing out that we can't access those. I think, did we have a way of getting those that was like a get thing? I thought we wrote one of those. This is it. Right? So that's how we were getting around that before. So yeah, this again is not code that will stay there, I don't think. Oops. So we should be able to do MAI, MAI. And that will again prevent Clang from complaining, because for some reason it's defined two different ways on the two different platforms. No reason for this. Do not know why, but it just is. Okay. So in theory, we should be able to loft this up. I don't think we probably want these to be called M and MI. And I think now is probably a time where we want to start having our own SIMD. So I'll probably also just say, hey, maybe we'll do handmade SIMD .h .cpp, and that way we can just go ahead and grab these guys and put them in there. I'm assuming that we don't actually want these to be M and MI, but anyway, what we can also do is say all of this stuff can now be, because this is sort of SIMD-based things, we can put these guys in here, we can get all their operators in there, and that way we can use those later for anything that we want to SIMD. That's not how you spell SIMD. Not how you spell it. All right. So this guy needs to include that because I believe that needs to be included here. So it may be shared needs to have that. So maybe it's better to do it in here, let's say. Oops. And maybe I'll just go like, okay, maybe I'll say handmade simd.cpp is not a thing. There we go. So there we go. Such as the kid was suggesting to slow down the time to make sure it is now right. We can definitely do that. Although I should probably get over there first so I don't have to laboriously hop over too slowly. All right. Looks pretty solid. I don't see like... I can't... The only thing I can't tell is, are they possibly one frame lagged? You know what I'm saying? I can't tell. Right, because that could be a bug if they were one frame laggy. I will say they do seem to change position a little bit in a way that I'm not sure if they should. The problem is I don't know if their Z value is such that they should, but they do look like they change. They do look like they shift a little around in their grid squares. So I'm not sure. I feel like there may be a bug there. Yeah, I think they're definitely, because they're definitely shifting. I think I'm going to call that a bug, at least till we can prove otherwise. And they like waver back and forth, like it's really weird. So here's the really weird thing about it is, while we're in the middle here, we should not be doing any modifications to the particle systems at all, right? Because while we're scrolling to the left, it's just the camera offset that's doing it. It's only right there at the crossover point that we actually apply anything. So it just feels like they're getting transformed on like a higher plane. You know, like they're on like this plane, like they're up above. Or something. I don't know. That's a bit weird. That's gonna be an involved debug, I think. So we're gonna have to save that. I think for tomorrow. Not too long ago, you changed world coordinates to be S32 instead of U32. I think they were unsigned originally so that overflow would work correctly to have the world wrap around. But that will still work at the moment. Since we're centered around 0, I think having them be U32s doesn't actually matter. Like, I don't think we need that anymore. I could be wrong about that, though. Cyberpunk code Hobo, does the Z position of the particles not get affected by the perspective transform? Well, the perspective transform is... Oh, well, you know what? I don't know that we are setting... we don't set any floor transform for it, so it could be that they're on a different floor. Yeah, that's hard to say. Remember, only the floor relative height part of things is the only thing that... I'm sorry, the which floor you're on that gets set is the only thing that determines how you kind of slide relative to other things, perspective transform wise. And so your height above the floor doesn't do that. But I don't remember. I don't remember what we set these to. So we set the floor Z here, right? And you know, for our particles, I don't really know what we want to do there for those transforms. That's a good question. When your position goes from int min to int max, won't it cause undefined behavior? Why would it cause undefined behavior? I don't think so, but either way, like, you can't get out that far. You'd never make it. Well, so yeah, the signed integer overflow, we don't, like, if the compiler is not going to treat that properly, then, you know, oh well. Like I said, you can't actually get out there, so I don't really care what happens. There's no way for the player to make it that far out, I don't think. And if for some reason we were worried about the player eventually getting there, we'd just make our chunk size bigger, because that's only used for the chunk size. If that makes sense. But I just don't remember if what we actually use them for. Yeah, see, we're using S32s for everything. We're not using U32s. So it's been that way forever. It's just, it was only the only code I changed that you're talking about was like in the little like world building like you know, this last screen Z nonsense, which is just, you know, irrelevant code anyway. It's just test code to create rooms for us to play with. I will say not having real 3D is just a real pain in the butt. There are so many things that you just can't do when you don't have real 3D. Yeah. Anyway, I'm going to go ahead and close things down here. It's late. All right, everyone, thank you for joining me for another episode of Handmade Hero. It's my pleasure coding with you as always. If you would like to follow along at home, you can always pre-order the game on handmadehero.org. It comes with a source code so that you can follow along. We also have a forum site you can go to if you want to ask questions. We have a Patreon page you can go to if you want to support the video series, a schedule bot that tweets schedule you, and an episode guide for catching up on old stuff. I will be back here tomorrow night, same time, same place. Until then, have fun programming, and I'll see you guys on the internet. Take it easy, everyone.